Assalamu alaikum warahmatullahi wabarakatuh. Before I start my presentation, I would like to introduce myself. My name is Mohamed Medhat Nemr. I am a petroleum engineering student at University Technology Petronas. My supervisor from Texas A&M University is Professor Hisham Nasruddin, and my supervisor from University Technology Petronas is Dr. Noor Eliana Ismail. Today, I am going to present about my student industrial project. My project title is Evaluation of New Acidizing Fluid that might be used for acidizing treatment. The outline. Firstly, I will give an introduction about my project, followed by a background and literature review, methodology, results and discussion, conclusion, recommendations, and lastly is the references. Introduction. Several studies have estimated that more than 60% of the world's oil and 40% of the world's gas reserves are located in carbonate reservoirs. The Middle East, for example, is surrounded by carbonate fields with around 70% of oil and 90% of gas reserves held within the carbonate reservoirs. In that map, you can see at the Middle East area, most of its land is a carbonate reservoir. The blue, the blue color shows that oil which is located in the carbonate reservoir. Background and literature review. Improving of the reservoir productivity is a very difficult process. As to achieve that process, the flow restrictions which is located near the well bore must be removed in order to enhance the oil productivity. There are two main reasons of impaired productivity, which are formation damage near the well bore or poor permeability of the reservoir. Acidizing of the carbonate reservoir is very a common technique used to restore and enhance production by dissolving a small fraction of reservoir rock to create a highly conductive channels. Two types of acidizing are usually conducted, which are matrix acidizing and acid fracturing. For carbonate reservoirs, acid fracturing is usually used. The main application of the acid fracturing is to stimulate low permeability reservoirs. Conductive wormholes usually created by the acid that will increase the conductivity between the well and the formation. In result of that, the permeability will increase and optimum oil recovery could be achieved. As you see in that figure, the acid is pumped into the fracture. As it etches the fracture, acid create conductive wormholes which increase the permeability and enhance the oil productivity. Increasing the productivity from those reservoirs is very difficult, as there are a challenge with the simulation flows due to the high temperature at the bottom hole. One of these challenges is the high reaction rate between the carbonates and the HCl. That will limit the HCl penetration through the carbonate formation, especially at the locations of low pumping rate. Besides the high rate of reaction, HCl is very corrosive to well tubular. Expensive corrosion inhibitors are used for protection at high temperature, but it only lasts for a short period of time. In order to decrease the rate of reaction of the HCl, gelling, emulsifying, or adding viscoelastic surfactant to the used solution might be applied. Corrosion inhibitors are always used in the acidizing treatment, as it keeps the tubulars and the equipment safe and away from being corroded. The selection criteria of the inhibitors depend on the time of exposure and temperature. Corrosion inhibitors are very expensive and they are considered as the most expensive component in the treatment. But in compared to the damage that might happen to the pumping unit or tubular if we don't use corrosion inhibitors, the cost would be higher. Organic acids have been used in well simulation as they cause low corrosion to the well tubulars. Also, its reaction rates with the reservoir rock is very low in compared with the HCl. Formic, acetic, and lactic acids are some organic acids that have been used for stimulating the carbonate formation. Successful acidizing treatment depend on selecting the most suitable organic acid of the acidizing treatment. Acetic or formic acids are considered as less aggressive acid type. They are considered as good alternative to the HCl, especially in high temperature wells. Organic acids spin slower on carbonate rock, providing deeper penetration and improved stimulation. Organic acids are used to stimulate high temperature wells where corrosion rates due to the HCl are very high. Organic acids mixtures have been used to stimulate high temperature and pressure wells for the carbonate reservoirs and to remove calcium carbonate scales in gas wells as well. Organic acids have some limitations, and that was mentioned in the old literatures. Firstly, they cannot be used at high acidic concentrations. The degree of hydrogen ion generation decreases with the increasing of the temperature. The cost of the organic acid is very high, higher than the HCl for equivalent mass of rock dissolved. Evaluation of the stimulation fluid usually depends on the evaluating according to different criteria. Interfacial surface tension test is one of the most important criteria as it is an important property in EOR. Corrosion tests need to be done in order to evaluate the corrosive effect of the stimulation fluid. Core flooding is also required for studying the effect of the injected fluid on the sample rock. Thermal stability tests need to be conducted in order to study the thermal decomposition degradation that might happen to the stimulation fluids under high temperature. The methodology. First phase is about measuring the interfacial tension for the new simulation solution. Drop shape analysis is a convenient way to measure the surface tension using the bend and drop method. Surface tension is determined by fitting the shape of the drop to Young-Laplace equation, which relates interfacial tension to drop shape. We have used the specific conditions, which are temperature 250 Fahrenheit, pressure 1000 psi, gas is the nitrogen gas. Surface tension measurements were carried out by generating a bend and drop at the end of the capillary tube, which they call it needle, which have outside diameter equal to 1.575 mm in compressed nitrogen gas. An image of the drop was recorded using a digital camera, and the drop shape was digitized. Besides that, before starting the experiment, we have to key in the solution density and the gas density and the temperature used. All of these data are digitized by the software and it helps it to calculate the surface tension. Here is the setup of the DSA, the drop shape analysis equipment. We have light source, we have the cell which is inside the chamber, we compress the gas and create the bubble. And also we have a solution source and gas source. And also we have a digital camera that captures the drop. Second phase. Second phase is about measuring the corrosion rate for the new solution. Corrosion is the loss of metal due to chemical reaction between the fluid and the exposed metal element, which its structure might be destroyed. It can happen either at bottom hole or in surface lines and equipment. Corrosion coupons are used in as a corrosion test, as a test material. Also, bits and cracks should be examined in order to get a clear idea about the effect of the acid on the metal coupon. We have used the specific conditions, which are temperature 250 Fahrenheit, pressure 1000 psi, gas, nitrogen gas, and we have did two tests for corrosion. The first test we have used superchromium coupon, and the second test we have used carbon coupon C95. And the duration of the test was 8 hours continuously. The autoclave, it is the chamber that we put the solution inside and the coupon inside in order to look the effect of the solution to the metal coupon. The autoclave was brought up to a pressure of 700 to 800 psi using the nitrogen gas. The temperature of the autoclave should be heated to the desired temperature. The pressure rose further up to 1000 to 1200 psi. As soon as the desired temperature is reached, the timer was started. The pressure of more than 1000 psi was maintained during the whole test. After 8 hours, the autoclave was cooled using water for 20 minutes. Then the unit was opened and the steel coupon is retrieved. Spent acid was collected and analyzed with ISP for metal content. Third phase. Third phase is about conducting core flood experiment on Indiana limestone core. The core flood is usually used to identify the options of the optimum development of an oil reservoir. It is also useful in studying the effect of the injected fluids on the sample rock. That studies are very useful in evaluating the acidic treatment. Conditions: temperature 250 Fahrenheit, injection rate 5 ml per minute, core is Indiana limestone, size 6-inch long, 1.5-inch in diameter. The core was war-dried in an oven at temperature of 250 Fahrenheit. Then the weight of the dry core were obtained. Then the core was saturated with DI water under a vacuum for 24 hours. The core was re-weighted and the weight of the saturated core have been obtained. The pore volume of the core was calculated using the formula. Pore volume equals saturated weight minus dry weight over the density. The initial permeability of the Indiana limestone core was measured using the core flood setup. The permeability were measured using DI water with 4 different flow rates, which are 5, 4, 3, 2 ml per minute. The pressure difference for each flow rate have been detected by the pressure transducer, which is connected to the computer. The initial permeability of the core have been calculated using Darcy equation, Q equal K A delta B over mu L. A core flood setup was constructed to simulate an acidic treatment. A back pressure was applied to the system. Pressure transducers were connected to the computer to record the pressure drop across the core during the breakthrough experiment. A syringe pump was used to inject the new acidic solution into the core. We have started injecting deionized water into the core with a flow rate of 5 ml per minute. After 20 minutes, we started to inject the new acidic fluid. Breakthrough samples was collected for each 2 minutes using fracture collector in order to analyze it with ICP equipment. CT scan images have been taken to the core before and after the core flood in order to detect the channels caused by the acid. Here is the core flood setup. We have used pressure transducer, computers, acid accumulator, pumps, overburden pressure pump, core holder, heating system, back pressure regulator, fraction collector. Force phase. Force phase is about conducting thermal stability tests for the new solution. There are many thermal stability techniques used in order to evaluate the stimulation fluids from the thermal stability point of view. Hot rolling oven technique usually used for heating the stimulation fluid using the still aging cell. FTIR equipment used for analyzing the chemical characteristics of the stimulation fluid after heating. Conditions: temperature 250 Fahrenheit, pressure 300 psi. Method: still aging cell. Non-stick linear cup was filled by the fluid stimulation solution in order to prevent any contact between the solution and the still aging cell. Then it was pressurized using the nitrogen gas till 300 psi. Then it was heated to the desired temperature 250 Fahrenheit using the roller oven for 6 hours continuously. After 6 hours, the aging cell was cooled down using water for 15 minutes. FTIR tests have been done before and after heating the solution in order to study the effect of the heating on the chemical characteristics of the stimulation fluid. Here is the linear plastic cup, the steel aging cell, and the FTIR equipment. Results and discussion. Interfacial tension. Interfacial tension measurements were carried out by generating a bending drop at the end of capillary tube. The result drop have been in compressed nitrogen gas. An image of the drop was recorded using a digital camera after 15 minutes of creating the bubble, in order to give the bubble a suitable time to stabilize with the surrounding nitrogen gas. The result of the IFT was 32.51 at the bubble volume equal to 8.65 67 cm cube. According to the IFT results, the IFT of that stimulation fluid to the nitrogen gas is very high, which means that the new stimulation fluid cannot be used for the acidizing treatments of the carbonate reservoir, as the producing company was expecting a very low interfacial surface tension result. Some ideas have been introduced to the producing company in order to decrease the surface tension of their fluid. A non-ionic surfactant have been recommended in order to decrease the surface tension of the new simulation fluid, so it can be more effective for the field applications. Corrosion test using the superchromium coupon. According to the corrosion test results, the corrosion rate of the new stimulation fluid using the superchromium metal test coupon is 0, as the pitting index is 0. By getting 0 pitting index for the superchromium metal test coupon and no change in the fluid color, this means that the new stimulation fluid will not have any corrosive effect on the tubular that contains superchromium metal. And here is a picture for the coupon before and after. The corrosion rate for the S13 chromium coupon is 0.00579, which is very good as the limit is 0.05 and it is below the limit. ICB test results was conducted on the solution which was collected after the corrosion test. We have looked for some elements like the iron, molybdenum, nickel, chromium. Corrosion test C95 coupon. According to the corrosion test results, the corrosion rate of the new stimulation fluid using the C95 metal test coupon is very high, as by analyzing the metal coupon after the test, we have found that the coupon is corroded too much, and most of the coupon have dissolved in the acid, which have changed the acid color from yellow to black, as you see in the picture. Test results for C95 coupon is 1.1853, which is too much. And you can also notice from the picture of the coupon before and after the test how much it is corroded. And that result is not acceptable at all. ICB test results for the C95 coupon showed to us for the iron and manganese 19.98, 1.084 before multiplying by the diluting factor, which was 2000 ppm. Recommendations was given to the company in order to increase the effect of their solution in the field application. We have asked them to add corrosion inhibitor in order to decrease the mentioned results, which was 1.1853 for the C95 coupon. And also we have asked them to do one more corrosion test for the L80 or N80 coupons. Core flood test. Measuring the initial permeability using 4 different flow rates, as we see that there is 4 different flow rates, and in each flow rate we have detected the delta B, which was for the first flow rate 90.257, then 72.973, 55.086, 36.974. The initial permeability was calculated using Darcy equation, and we have created a permeability correlation between the 4 flow rates, and we have got that straight line with this equation, so the initial permeability is calculated by 18.4 millidarcy. The core flood breakthrough test have been conducted using a flow rate of 5 milliliter per minute. That result shows that the amount of acid used till the breakthrough was about 1.33 of the pore volume. And here you can check the graph. Here is the core after the core flood experiment, and here is the samples that we have collected. Here is the CT scans that have been conducted on the core flood, on the core after the core flood, and here we can see that how the acid penetrates the core and the wormholes which was created. Here is a table of the ICB test results for 11 samples which was collected during the breakthrough experiment. We was looking for the calcium, magnesium, manganese, and chromium. And we have drawn a graph with the concentration to the cumulative pore volume for the following for the elements that we have checked with the ICB, which was calcium, magnesium, manganese, chromium. Thermal stability test. By using the aging cell thermal stability test method, and heating the solution for 6 hours under pressure of 350 psi and temperature of 250 Fahrenheit continuously. Then analyze the solution components using the FTIR equipment. We have found that the solution is very thermal stable and no degradation have happened. Here is the graph which shows that FTIR test result before heating, and here is the FTIR test result after heating. And we can compare them and they are totally similar. Conclusion. The objective of this project is achieved as the evaluation of the new stimulation fluid is successfully assessed. Evaluation criteria of the corrosion rate, interfacial tension, and thermal stability and breakthrough of core flooding have been carried out using the specified methods as mentioned in the methodology. Recommendations have been submitted to the company which agree on it. Some recommendation for Texas A&M and for UTB. To provide the new and current students with a visual material that they can learn from it how to use the equipment, and it can be a reference for them. To provide a regular safety training for the students. Recommendation for UTB. To increase the period of the SIP and decrease the period of the SIT, so the students will have much time in order to finish their project in a time manner. Also to pay the intern students an allowance in case the host company do not provide. Here is the reference that I have used during writing my report and conducting the experiment and in the presentation as well. Thank you so much and have a good day.